Hello students, today we shall see some particular types of functions and their graphs. First function we are considering here, identity function. What is identity function? If the image of an element is identical with the element itself, then it will be called identity function. We are formally defining. The identity function on a non-empty set A is denoted and defined as this. IA is a function from A to A, such that IA of x is equal to x for all x belongs to A. See, IA of x equal to x means IA of x is the image, but this image is again equal to the element itself. Image is identical with the element considered for all elements, of course, in the domain, and that's why name is identity function. And with the concept of relation, if we want to define identity function, then it will be IA equal to the set of all ordered pairs with first component and second component as same element. First component identical with second component for all x in the domain set capital A. This is identity function, because every function is also a relation. So this function is defined in terms of relation. And it is also denoted by simply I. Instead of IA, we can denote it by I, identity function, if there is no confusion about the set capital A. The set A may be AX, may be B also. Here it is A. But mainly we shall consider identity function on the set of real numbers. That's why again we are defining the identity function on the set of real numbers capital R is denoted and defined by I, a function from R to R, such that Ix equal to x. Image of x under I is again x itself, identical for all x belongs to R. The domain, codomain, and the range of identity function I in this case are all same as capital R. All are R. Now, to draw the graph of this identity function, we first construct the table of values of x and ix. But when we draw the graph of a function f, we consider the equation y equal to fx. So here y equal to fx becomes y equal to ix, and ix itself is x. That's why y equal to x. So y and x are same, means when x is 0, y is 0, x is 1, y is 1, x is 2, y is 2, etc. Some positive values, and again let us give some negative values. X is minus 1, y is minus 1, x is minus 2, y is minus 2, etc. Now if we plot these points, x0, y0 means origin, x1, y1 means this point 1, 1, 1 comma 1 point is this, then x2, y2 means 2 comma 2, this is 2 comma 2 point, this is 3 comma 3 point, x3, y3. Similarly, minus 1 and minus 1, x is minus 1, y is minus 1, this is the point, x is minus 2, y is minus 2, this is the point, x is minus 3, y is minus 3, this is the point. So after plotting, if we join them, we see that we get a straight line extending up to infinity, passing through origin, making an angle 45 degree with x-axis and 45 degree with y-axis. So this is the graph of the identity function. Second function we consider is constant function. A function f from a set A to a set B is said to be a constant function if f of x equal to c for all x belongs to capital A. That means image of all the elements of the domain is a single element. C is A. You can denote it by C, K, lambda, anything. We have written here C. And this C is what? C is a fixed element of B, and that we usually call constant, fixed element of the codomain capital B. So every element is mapped onto the same element. Then the function is constant function. You can see in the figure every element here mapped onto the single element C of the codomain. Here it is domain. This is A, our A set, and this is the set B. So the range of this constant function is the singleton set, second bracket C, only one element. So in short, we can say that A constant function is a function whose range is a singleton set. And on the set of real numbers, if we again define the constant function, and this is a function f from R to R such that f of x equal to c for all x belongs to R, because we shall concern with only functions on the set of real numbers, where f(x) equal to c for all x in R, where c is a fixed real number, and fixed real number means constant. That's why the name is constant function. Now the graph of this constant function is a straight line parallel to x-axis, because you see f(x) equal to c means y equal to c. Y is constant. If when y is constant, it represents a straight line parallel to x-axis. And let us take c as minus 1.5 once and c as 2 again. Then what will be the graph? For this c equal to 2, when c is 2, fx is c, means fx is 2. That is y equal to 2 always. See in this table, y is 2 always, y is 2. And x 0, 1, 2, 3, minus 1, minus 2, minus anything you give, y is always 2. So if we plot these points, obviously we see that we get a straight line at a height 2 unit from x-axis, above x-axis. Y is 2 always. So this is the straight line parallel to x-axis corresponding to c equal to 2. And if we take c equal to minus 1.5, then fx will be equal to minus 1.5. Means for any value of x, y is minus 1.5. See here, y is minus 1.5 always, and x is as before 0, 1, 2, 3, minus 1, minus 2, minus 3. Now if we plot these points, then and join them, we get a straight line at a depth of 1.5 unit below x-axis. So this is y equal to minus 1.5, straight line parallel to x-axis. So constant functions geometrically represent straight lines parallel to x-axis. If c is positive, the line will be above x-axis. If c is negative, the line will be below x-axis. Now in particular, the constant function may be like this: fx equal to 0 for all x belongs to R, means c is 0 here. Then the graph of this function, this constant function, is the x-axis, because fx equal to 0 means y equal to 0, and y equal to 0 means x-axis. And this function is called the 0 function. Fx equal to 0 for all x, 0 function. Geometrically, it is the x-axis. Number 3 function we are considering is polynomial function. A function f from R to R, set of real number to set of real number, is said to be a polynomial function if it is given by y equal to fx equal to a naught plus a1x plus a2x square plus a3x cubed dot 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 an x to the power n, where a0, a1, a2, a3 dot 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 an are constants, that is the real numbers in our case. And if an, a suffix n, last coefficient of highest degree term, is not 0, then fx is called a polynomial of degree n. X is variable, a0, a1, a2, a3 dot dot an are constants, and of course the powers are positive integral powers. Then this fx is called a polynomial of degree n, and the corresponding function f is called a polynomial function. You can say that fx is also a polynomial function. For example, if I write fx equal to 5x to the power 4 minus 2x cubed plus 3x plus 7 for all x belongs to 1, this is a polynomial function. This defines a polynomial function of degree 4. Highest degree here is 4. The domain of any polynomial function is capital R, means set of all real numbers. X can be anything, any real number, no problem. Now let us draw the graph of the particular polynomial function y equal to fx equal to x square, and another y equal to fx equal to x cube. Most simple polynomial function, second degree polynomial function. Here it is third degree polynomial function, simplest one. Now for first one, y equal to fx equal to x square, we construct this table: values of x 0, 1, 2, 3, minus 1, minus 2, minus 3, some positive values, some negative values, and 0 generally we keep. Then y equal to x square, so 0 square is 0, 1 square is 1, 2 square is 4, 3 square is 9, like that. Minus 1 square is 1, minus 2 square is 4, minus 3 square is 9. Now if we plot these points 0 0 origin 1 1, this is the point 1 1, this is the point 2 4, this is the point 3 9. Similarly, this is minus 1 comma 1 point, this is minus 2 comma 4 point, this is minus 3 comma 9 point. And y equal to x square means y is always positive or 0. So the graph lies above x-axis, and this time we are not getting a straight line. Y equal to x square is not a first degree equation. A first degree equation gives a straight line. Here is a second degree equation, and the graph is as in this figure. It will extend up to infinity in this direction and also in this direction. The graph of the function y equal to f x equal to x square is a curve lying in above x-axis and passing through the origin as in figure, and it is called a parabola. This name of this curve is parabola, which is symmetrical about y-axis. Symmetrical means see the graph to the right side of y-axis is exactly same as graph to the left side of y-axis, as if y-axis is mirror and this portion is mirror image of that portion. So then this is called symmetrical about y-axis. Second one, y equal to f x equal to x cube. This time the table is this: y equal to x cube 0 0 1 1 2 2 cube is 8 minus 1 cube is minus 2 cube is minus 8. So this is a big number, that's why you have given only less number of points here. So if we plot these points, first point is 0 0, this is 0 0, this is 1 comma 1 point, and this is 2 comma 8. When x increases slightly, y increases rapidly, so suddenly 8. Similarly, x is minus 1, y is minus 1, but when x is minus 2, y is minus 8. So this is the graph extending up to infinity, passing through origin. The graph of the function given by y equal to f x equal to x cube for all x belongs to r is a curve passing through the origin and lies in the first and third quadrant as in figure, extending up to infinity in both the upward and downward directions. Then number 4 functions. Rational algebraic function. What is that? If px and qx are two polynomials, what is a polynomial? We know in the definition of function in number 3 we have seen polynomial function. Now we are defining rational algebraic function. If px and qx are two polynomials, then the function f defined by fx equal to px by qx, ratio of two polynomials. Where of course denominator qx should not be 0, not 0, is called a rational algebraic function. Ratio of two polynomials provided denominator is not 0 is called a rational algebraic function. The domain of this function is the subset of the set of all real numbers, capital R, for which qx not equal to 0. If qx 0 meaningless, that's why all those x, values of x for which qx not 0 will constitute the domain. For example, suppose fx equal to 2x cube minus 4x plus 3 by x square minus 5x plus 6. Then this defines a rational algebraic function because it is polynomial by polynomial, and its domain is r minus second bracket 2 comma 3, means all real numbers except 2 and 3. Why? Because denominator here x square minus 5x plus 6 is actually x minus 2 into x minus 3, and this becomes 0 when x equal to 2 and x equal to 3. When x equal to 2 and x equal to 3, denominator becomes 0. So this makes undefined. This ratio becomes undefined, so this is to be omitted. That's why domain is r minus second bracket 2 comma 3. Let us draw the graph of the particular rational algebraic function defined by y equal to fx equal to 1 by x. Simplest, 1 by x. For all x belongs to r minus second bracket 0 means all real numbers except 0, because when x is 0, this fx is undefined. Now this time what we see, x and y is 1 by x. So when x is 1, 2, 3, x is 1, 1 by 2, 1 by 3, like that. When x is minus 1, minus 2, minus 3, y is minus 1 by 2, minus 1, minus 1 by 1. Sorry, this should be minus 1. This should be minus 1, not 1 by 2. This is just minus 1. Minus 2, minus half, minus 3, minus 1/3. And now if x is half, y will be 2. If x is 1/3, y will be 3. Reciprocal of 1/3 is 3. X is minus half, y is minus 2. X is minus 1/3, y is minus 3. So if we plot this, what we notice that if x is positive, y is positive. First quadrant. If x is negative, y is negative. Third quadrant. So the graph is like that. And here one thing we notice that if we increase x, then y decreases. When x is very very large, y will be very very small. So the graph approaches x-axis here in this direction. Similarly, when y is very large, x will be very small. That means the graph approaches y-axis in the first quadrant. Similarly, in the third quadrant, same mirror image as if. So the graph of the function defined by y equal to fx whole 1 by x consists of two infinite arcs. These are two arcs. It will extend up to infinity. Two infinite arcs not meeting coordinate axis. The distance between the graph and x-axis will decrease and decrease when x becomes larger and larger, but will not meet x-axis. Lying in the first and third quadrants as in figure above, and it is called a rectangular hyperbola. The name of this graph is rectangular hyperbola. We shall get these things in second year coordinate geometry. Also parabola, hyperbola, ellipse. We have seen their parabola previously. This is parabola and this is hyperbola. Now next function, mod function or modulus function or absolute value function. Modulus function. The function f from set of real numbers to set of real number defined by fx equal to mod x for all x belongs to R is called mod function or modulus function or absolute value function. But what is mod x? The meaning of mod x is x. Mod x equal to x if x greater than 0. If x is positive, then mod x is x. If x is 0, then mod x is 0. If x is negative, then we know mod x is positive. That's why we have given here minus x. Mod x is minus x. If x less than 0. A confusion always arises. How can mod x becomes minus x? See, x less than 0 means x itself is negative. Therefore, if we give another minus sign before x, automatically it will be positive. So that's why mod x is x, 0, minus x, depending on the values of x. As an example, I have set it like that. Mod 5 is 5, x is 5 is positive, so mod 5 is 5. Mod 0 is 0, mod half is half, etc. Now, mod minus 5 is 5 because absolute value, magnitude we have to take. Now, this 5 I can write as minus 5, which can be written as mod x equal to minus x. See, if you take minus 5 as x, then automatically minus x will be 5. So that's why mod x equal to minus x when x is negative. X is minus 5 negative. Similarly, mod minus half will be half, and that half I can write minus half. Means again I can write mod x equal to minus x, where x is minus half. Now to draw the graph of this mod function, for which we construct the table of values of x and y to draw the graph. What is that? Y is mod x and x. X is 0, 1, 2, 3, minus 1, minus 2, minus 3 everywhere. But y is always mod x means value magnitude will be same, only minus and you are to omit. So all values of y are equal in magnitude to that of x. So if we plot these points 0, 0, 1, 1, 2, 2, 3, 3 like that, we get this straight line extending up to infinity. This portion is x greater than equal to 0 portion. And if x is negative, minus 1, minus 2, minus 3, then again y is positive. So if we plot, again we get another straight line from origin going to infinity. So the graph of this mod function consists of two rays, rays. This is called ray, extending up to infinity, straight line with on one endpoint. Ray. So two rays with a common endpoint at the origin as in figure. Another thing here, directly mod function we can write like that: fx equal to x if x greater than equal to 0, and fx is minus x if x less than 0. Because when x is 0, f0 is 0, mod 0 is 0. So instead of 3 lines, we can use these 2 lines only. So graph of mod function is drawn. It is symmetrical about y-axis. See, as if y-axis is mirror, and then in that case the image of this ray straight line will be this straight line in the second quadrant. Mirror image, symmetrical, like parabola. Now one note we see here, fx is mod x for all x belongs to R. Now f of minus x is mod minus x, but mod minus x will be same as mod x, but mod x is again fx. So what we have got, f of minus x equal to fx for all x belongs to R, means sign has no effect. Image of x, image of minus x are same under the function, and such a function is called an even function, and whose graph is symmetrical about y-axis. May not be straight lines, maybe parabola also symmetrical about y-axis. Even function, f of minus x is f of x. All of you know cos minus theta equal to cos theta. In class 10 you have got, we shall see again in trigonometry, like that. Cos minus x will be cos x. Here f of minus x is fx. Image of x and minus x when same, the function is called an even function. Next function is our signum function. Number 6 function, signum function. The function f from R to R, defined by real to real, defined by fx equal to mod x by x if x not equal to 0, and value of fx is 0 if x equal to 0. Then here if we put 0, meaningless, undefined, that's why separately value is given as 0. Now what is mod x? Mod x is again x by x. It will become x by x if x is positive, and this is 1. Now if x is negative, this mod x will become minus x. So minus x by x, this will become minus x by x, it becomes minus 1 if x less than 0, and if x is 0, already here it is given 0, therefore here also 0, means 1 minus 1 and 0. So you can simply say fx is 1 if x greater than 0, minus 1 if x less than 0, and 0 if x equal to 0. So this may be taken as definition of signum function, this one line or this line. And this is signum function. The domain of this function is the set of all real numbers R, and range is the set. See, there are three values only, 1, minus 1 and 0. Set of all images, only three images. So this is the range, minus 1, 0, 1. To draw the graph of the signum function, first we construct the following table. Y equal to fx and x 0, y 0. By definition, when x is 0, y is 0. Then when x is minus 0.1, y is minus 1. See, when x is less than 0, y is always minus 1. So I give minus 0.1 or minus 1 or minus 2 or minus 3, always y will be minus 1. And if x is greater than 0, y is already 1. Y means fx is 1. So if I give 0.1, 1, 2, 3, anything, y will be always 1. So if we plot these points, first is 0, 0. This is the point 0, 0. This is the point 1, 1. This is the point corresponding to x is 0.1, y is 1, and 1, 1 means this is 1, x is 1, y is 1. So this is the point 1, 1. This is the point 2, 1. This is the point 3, 1. So if we join, we get a straight line. Similarly, if we plot this point, x is minus 0.1, y is minus 1. X is minus 1, y is minus 1. X is minus 2, y is minus 1. X is minus 3, y is minus 1. So this is also a straight line going in this direction, left side direction. This is to the right side direction. But one fact, here is a gap I kept. When x is minus 0.1 or 0.1, see, y is here minus 1, y is 1. But when x is 0, suddenly y is 0. So there is a huge gap. You cannot join these two origin, and this straight line does not meet y-axis. This straight line also does not meet y-axis. So the graph consists of two parts of two straight lines. This is a part of a straight line because left side is not there. This is a part of a straight line, like right ray. This is a part of a straight line, like left ray, and this origin is also a point on the graph. So the graph consists of two parts of two straight lines corresponding to x greater than 0 and x less than 0, together with an isolated point. Origin is an isolated point at origin, but the two parts of the two straight lines do not meet y-axis. You cannot join this with y-axis. So this is the graph of signum function. Then again and again we have used the word graph. Mathematically, what is graph actually? Here I have written graph of a function. The graph of a function f from R to R, real function, with domain a subset D of R. Domain may be subset of R, may not be equal to R. So suppose the domain is D, it is a subset of R. Then the graph of this function is the set of all points, first bracket x comma y, such that y equal to fx, and x belongs to the domain. Set of all points. Graph is a set. In the plane, R square means xy plane or Euclidean plane, you can say. So the graph is a set of points for which y equal to fx. And geometrically, it is usually a curve, as we have seen in hyperbola, parabola above, or a straight line, or pieces of straight lines, or arcs of curves, and sometimes together with a few isolated points, as if here a point at origin isolated, you cannot join it with this part of the graph or that part of the graph, so isolated point. So this is graph. Geometrically curve or straight line or arcs or together with isolated points. Number 7, greatest integer function or step function. The function f from R to R defined by fx equal to third bracket x for all x belongs to R is called the greatest integer function. What is the meaning of this third bracket x? So where third bracket x is the greatest integer less than or equal to x, means not exceeding x. Example will clarify it. Say if I take x is 2.3, third bracket 2.3 value is 2. Third bracket 2.9 value is 2, third bracket 2.99 value is 2, third bracket 2.01 value is 2 always, because 2 is the greatest integer not exceeding 2.3, not exceeding 2.9, not exceeding 2.99, not exceeding 2.01. So that's why third bracket 2.3, 2.9, 2.9 and all are equal to 2. Similarly, if it is 1.5, value is 1. If it is say here 1 is missed, 1.01, this should be 1. 1.01 value is 1, 1.9 value is 1, 1.999 value is 1, root 2 value is 1. What is root 2? Approximately it is 1.414 like that. So that's why 1. Here 0.1, third bracket 0.1, greatest integer function value is 0, 0.5, 0, 0.90, pi is 3. What is pi? Approximately pi is 3.1416. So that's why 3. So from this we notice that if x is a positive real number, then third bracket x is nothing but the integral part of x. 1.999. Integral part is 1, fractional part is 0.999. So to find the value of third bracket x for a positive real number, we just forget the fractional part. So this is easy to find the value process. But for negative, let us check. If x is minus 0.2, then the value of this third bracket minus 0.2 is not 0, it is minus 1. Minus 0.5 also minus 1. Minus 0.9 also minus 1. Why? Because minus 1 is the greatest integer not exceeding minus 0.9, minus 0.5 or minus 0.2. Similarly, minus 1.2, third bracket minus 1.2 is minus 2, minus 1.5 also minus 2, minus 1.9 and also minus 2. Third bracket minus root 2 is minus 2 because root 2 is roughly 1.414 like that. Minus pi is minus 4. The region I have written here. Minus root 2 lies between minus 2 and minus 1. Minus pi lies between minus 4 and minus 3. That's why minus 4 is the answer, minus 2 is the answer here. Oh, here one mistake is done. This is not third bracket minus 2. This is only this bracket is not there, only minus 2. This bracket is not there, only minus 2. Now in general, I am writing the values. Third bracket x is 0 if x lies between 0 and 1. Whether it is 0 or 0.1 or 0.2 or 0.9, no matter, all will give you 0. If x lies between 1 and 2, x including 1 but not including 2, then say 1.1, 1.2, 1.3, 1.9, 1.5, whatever it is, the third bracket x value is 1. If x lies between 2 and 3, excluding 3, the value is 2. Similarly, if x lies between -1 and 0, third bracket x value is -1. If x lies between -2 and -1, excluding -1 of course, third bracket x is -2, and so on. So here we see that if x is a negative real number, then third bracket x is obtained by omitting decimal part and decreasing integral part by 1 more. See, -1.2. If I omit decimal part, what remains? -1. But the answer is -2, means -1, decrease it by another 1, it will be -2. -1 means -2. That's the answer is -2. So, greatest integer function. Now, if we want to draw the graph of this greatest integer function, then first we construct the table. X lies between 0 and 1, excluding 1, value is 0. Just we have seen above. X lies between 1 and 2, value is 1, excluding 2. X lies between 2 and 3, excluding 3, value is 2, like that. And here also -1, -2, -3. So if we plot, see, when x lies between 0 and 1, excluding 1, y is always 0. So it is part of x-axis. When x lies between 1 and 2, 1 and 2, excluding 2, 1 to 2, then y, see, value of y is always 1. So parallel to x-axis, this part of the straight line. Similarly, when x lies between 2 and 3, y is always 2. So this is the graph. Here white circle we have given means excluding 3, here excluding 2. When x lies between 3 and 4, 3 and 4, y is always 3. So 1, 2, 3. So this is the portion of straight line here. Similarly, when x lies between 0 and -1, x lies between 0 and -1, and excluding 0 of course, y is -1. So this is the -1 portion. Similarly, when x lies between -1 and -2, excluding -1, excluding -1, y is always -2. So this is -2. Similarly, this is -3. So as if it is a staircase, step, step, step. That's the name of the function is step function also. The graph consists of line segments, each of 1 unit length, parallel to x-axis, not meeting the right-hand vertical dotted lines. Here, see, white circle means right-hand vertical dotted lines are not meeting. Gap is there, but it meets the left-hand dotted line. While meeting the left-hand vertical dotted lines, as in figure above, the graph is like staircase, and that is why the name step function is coined with it. Coined means attached with it. Next, algebra of functions. Addition, subtraction, multiplication, like that. Let f is a function from x to r, g is a function from x to r with the common domain x. Both are function from x to r. R means your set of real numbers. And what is x? X is a subset of r. Again, x is a subset of r here. So it's real function. F and g are real functions. Then the sum of f and g is the function denoted and defined by f plus g. F plus g is a function from x to r. It is again a real valued function such that f plus g of x is equal to fx plus gx. Normal definition. F plus g of x is fx plus gx for all x in x. Difference of f and g is denoted and defined by f minus g from x to r such that f minus g of x is fx minus gx for all x in x. The product of f and g is the function denoted and defined by fg is a function from x to r such that fg of x equal to fx gx. fx gx for all x belongs to x. Also, gf, here we have defined fg and here it is gf. Gf is a function from x to r such that gf of x is gx of x for all x. But gx of x can be written as fx gx because they are numbers, real numbers, commutative. 2 into 3, 3 into 2, same like that. fx gx, gx of x same. But this already you have written fg of x. So gfx equal to fg of x. That means gf and fg have same effect. So fgf equal to fg, both are equal. And this product, of course, this product is also called pointwise multiplication of the functions, fx into gx, pointwise multiplication. But There is another type of product of functions called composite of functions, denoted by GOF or G dot F or simply GF, for which GF not equal to FG in general. This we shall get in second year. The definition we are not giving here, it is something different. Number Roman 4, the product of f and a scalar k, scalar means a real number, is denoted and defined by kf. Kf is a function from x to r such that kf of x is k into fx. Normal definition, k into fx. K is a constant. Number 5, the quotient of f and g is the function denoted and defined by f by g is a function from x to r such that f by g of x is fx by gx. Natural definition for all x, provided gx not 0. If gx is 0, then this will become meaningless and there will be no quotient. So these are algebraic operations, rather algebra of functions, and here we stop today. Examples will be done later. Thank you.